acah-acah estetik pula. Realitinya, bila belajar tak adalah fokus mana. Hai, dah lah minggu depan test. Alah, test! Hai, semua bab dah belajar dah ni. Harap-haraplah esok yang aku bacanya masuk test. Makan pun dah tak boleh jalan lagi. Minum pun dah tak boleh jalan lagi. Solusinya mestilah tidur. Tak sabarnya nak tidur. Bestnya. Tidur. Tidur. Bestnya tidur. Apa pula ni?
Nur Aisyah, macam mana nak buat ni? Susahlah.
Acak. Macam ni je korang. Sini, tengok ni.
Chromatography is a technique used to separate the different parts of a mixture. It is especially useful when those parts are very similar and hard to separate by other methods. Chromatography was first developed by a Russian scientist named Mikhail in the early 90s. Chromatography has 4 phases or parts, which are paper chromatography, thin layer chromatography, column chromatography, and gas chromatography. Column chromatography is a separation technique which components of mixture is being separated by using a glass column packed with stationary phase and the liquid mobile phase flowing continuously through the column. Stationary phase is a solid material, usually silica gel or alumina, packed into a vertical glass column. Mobile phase is a liquid solvent that flows down through the column, carrying the components of the mixture with it.
Hi guys, the objective for this experiment is to separate the different pigments present in spinach leaves using column chromatography and to identify and analyze the pigments based on their color and movement through the stationary phase. Before starting this experiment, we need to prepare the apparatus and the setup, which is including a glass column, silica gel or alumina, beaker or flask, funnel, test tube or collection tubes, pipettes or droppers, solvent, and lastly, clamp and stand.
For the procedures, number 1, prepare the column. Fill the glass column with silica gel, tap gently to remove air bubbles and ensure an even packing. Number 2, add a small amount of solvent. Pour a little solvent into the column to wet the silica gel before adding the sample. Number 3, apply the sample. Using a pipette or dropper, carefully add the plant pigment extract on top of the silica gel without disturbing the surface. Number 4, add more solvent. Slowly pour the solvent mixture into the column. The column will start moving down through the silica gel. Number 5, collect fractions. Collect the liquid dripping out of the column in test tubes of containers, changing tubes at regular intervals. Number 6, observe separation. Watch for different colored bonds or layers forming as pigments separate. Common pigments include green chlorophyll, orange beta-carotene, and yellow xanthophyls. Number 7, continue until all pigments are collected. Keep adding solvent and collecting fractions until no more pigment comes out of the column. Number 8, analyze the results. Compare the colors and order of the separated pigments to identify them. For the results, for stationary phase is alumina and mobile phase is hexane. For the elution, we got beta-carotene, xanthophylls, and chlorophyll A.
Now, let's take a look look at the advantage and disadvantage of column chromatography. We're starting with the advantage. First, it's a robust method. It's reliable and works under a wide range of conditions. Second, it can separate any type of mixture, whether it's polar, non-polar or a complex mixture. Third, it can handle any quantity of mixture, from small analytical sample to larger preparative amount. And finally, the separated analyte can be reused, which will make it efficient and sustainable for many applications. However, like any method, it has its drawbacks. It is time consuming, especially if you work with a larger column or multiple fraction. It also can be expensive, particularly in terms of solvent use, since a large volume is often required for elutions, and it has relatively low separation power compared to more advanced methods like HPLC. So, while it is a powerful and versatile technique, it is important to consider this limitation depending on the goals of your analysis. In conclusion, it works based on two phases, a stationary phase like alumina or silica, and a mobile phase, which is typically a solvent such as hexane. In this case, the column is prepared by mixing alumina with hexane and pouring it into a glass column. The sample mixture is then added and moved through the column with the mobile phase. Separation happens because each compound interacts differently with the stationary phase based on its polarity. For example, beta-carotene being non-polar, elute first. Then, more polar compounds like xanthophylls and chlorophyll A are eluted later. So, overall, column chromatography is effective for separating and identifying components in a mixture based on their polarity and interaction with the column material.
Macam mana tadi CHM 26? Senang je kan? Apa-apa pun, kalau korang tak faham lagi, korang boleh je tanya lecturer korang. Itu je daripada kami. Bye!